Good morning, everyone. Welcome back. Thank you for joining us. We are glad that you're here. I'm Steve.
And I am Scott.
Together, we're Backyard Musings, the Science and Technology channel.
Yep, and we are talking about another space topic today. So some of you may be familiar with this constellation that this little white dwarf is in, but we'll get into it.
A naked eye star's 50-year mystery is solved. So when they say naked eye, that means you can look up in the sky and you can see the star.
Yeah, please don't take your clothes off.
What?
Whatever you do, don't go outside and take your clothes off to look at the star. Yeah.
Its bizarre X-rays come from a hidden, feeding white dwarf, easily visible in the night sky within the constellation Cassiopeia. The star Gamma Cas, that's the Greek symbol, I was going to say French, Greek symbol gamma. And then
I'm glad you said that because I was going to say YCAS. So I'm glad you said that.
Has puzzled astronomers for more than 50 years. It produces X-rays with energies and temperatures far beyond what is expected from a typical massive star. Would you like to know more?
Okay, new observations using the Resolve instrument aboard Japan's XRISM space telescope. And I don't know what that stands for, but it's got to be, I'm sure it's got to be good, like the James Webb or Hubble, right?
Yeah.
Now trace this unusual emission to a white dwarf orbiting the star. This finding also confirms a long theorized class of binary systems that had never been clearly identified. The study, led by researchers at the University of, is that Liège? Liège? Yeah. Was published in March of 2020, March 24th of this year in Astronomy and Astrophysics.
Why Cassiopeia was the first BE-type star identified, a classification introduced in 1866 by Italian astronomer Angelo Secchi. These stars are massive and rotate extremely fast, periodically ejecting material into space. That material forms a surrounding disk, which can be detected through distinct features in the star's optical spectrum.
So that almost looks like a little fountain.
Well, the picture you're looking at now is a UFO tethered to another UFO that's in trouble and needs help.
Okay. All right. In 1976, which I don't know, were you? Yeah, you were alive in 1976.
Yeah.
Scientists discovered that Gamma Cassiopeiae. Is that right?
Cas emits X-rays, yeah.
Oh, Cas is just short for Cassiopeia, okay.
Yeah.
X-rays about 40 times more powerful than those of similar massive stars. The plasma producing these emissions reaches temperatures above 100 million degrees and fluctuates rapidly. Over the next 2 decades, space-based observations identified about 20 stars with similar behavior, forming a group known as Gamma Cas analogs. Researchers at the University of Liège played a key role in this work, identifying more than half of those objects, or these objects. Okay.
Moving forward here. Quote, several scenarios have been proposed to explain this emission, explains Yael Naze, an astronomer at the University of Liège. One of them involved local magnetic reconnection between the surface of the BE star and its disk. Others suggested X-rays to be linked to a companion, whether a star stripped of its outer layers, a neutron star, or an accreting white dwarf.
Okay. Earlier studies had already ruled out stripped stars and neutron stars because observations did not match theoretical expectations. That left 2 possibilities: magnetic interactions involving the star itself, or an accreting white dwarf companion. Until now, there was no clear evidence to decide between them. Interesting.
To resolve the mystery, the team carried out a dedicated observing campaign using Resolve, a high-precision microcalorimeter on board XRISM, that is transforming the study of high-energy astrophysics. Observations were taken in December 2024, February 2025, and June 2025, covering the full 203-day orbit of the system.
This is a quote. The spectra revealed that the signatures of the high temperature plasma change velocity between the three observations following the orbital motion of the white dwarf rather than that of the B star. That's BE star. The researcher continues. Going on with the quote, this shift was measured with high statistical reliability. It is, in fact, the first direct evidence that the ultra-hot plasma responsible for the X-rays is associated with the compact companion and not with the B star itself, unquote.
The data also provide clues about the nature of the white dwarf. The observed spectral features have moderate width of the order of 200 kilometers per second, which rules out a non-magnetic white dwarf, of course. In such systems, material would spiral in through the inner disk at very high speeds, producing much broader signals. Instead, the findings indicate a magnetic white dwarf where the disk is truncated and the magnetic field directs incoming material toward the object's poles.
These results establish that Gamma Cas and similar stars belong to a class of B+, that's again, BE+, white dwarf binary systems. It had long been predicted but never clearly observed. The research team also identified two notable traits of this group. It mainly involves massive B stars and represents about 10% of them. However, theoretical models have predicted a larger population and suggested a stronger link with lower mass B stars.
Quote, this discrepancy suggests a revision of binary evolution models, particularly regarding the efficiency of mass transfer between components, a conclusion that aligns with that of several recent independent studies. Solving this mystery therefore opens up new avenues of research for years to come. Understanding the evolution of binary systems is crucial for comprehending, for example, gravitational waves, as it is indeed massive binaries that emit them at the end of their lives, concluded Yael Nazé.
Okay, well, looking at that last slide, there's a couple of other stars, I guess you could say, that were noted on there that we used to study when we were younger, doing astronomy as a hobby. So, and in Boy Scouts, when we were in Boy Scouts, we used to do that. So, Cassiopeia was one of them. I think the Ursa Minor was up there. Andromeda was up there.
Yeah. Perseus.
Yeah, I don't remember some of those other ones. Oh, Cepheus. That was on there. Yeah, that's one of the. So Cassiopeia, we used to call that the chair.
Oh yeah, it looks like a chair.
Kind of shaped like a barber's chair or a chair.
Yeah.
And then I'm trying to think. There used to be one that was like a kite, but I don't see that one on there. Oh, that's
isn't that the Southern Star, the kite, the Southern Cross?
I don't know. Maybe, could be. But yeah, I don't see that. Maybe it's around on the other side. But there's a really cool app that you can get, I guess, for your devices like your phone or your iPad or no, whatever the other devices are. I don't know what they are. I got an iPad, so I know what that is. But you can look on there and see, point it up into the sky, and it'll point out all the constellations for you. So my grandkids used to do that. I had no idea how to do that. I've never done it since, but it's a pretty cool tool.
Yeah, it's called Skyview is the app.
Skyview.
Skyview. And you just hold it up, and it looks and it sees what's there, and it tells you the moon, or it tells you Cassiopeia or Ursa Minor, Little Dipper, Big Dipper.
That's very cool.
It is cool. And then you can go down below your horizon, and it'll show the planets that are down there. You know,
you can't even see. You can't even see then. Really, it'll tell you what's there.
But they show up based on where these are. It predicts where those are.
Wow, I'll have to try that.
It's pretty cool. Skyview. Skyview.
SKY View.
Yeah, and we don't. They're not a sponsor.
No, should be though. As much as we talk about space. So, anyway, thanks.
All right, folks. We'll see you this afternoon.
Take care, everyone. Thanks.